All right, so very first question we have, it's a, again, square root kind of question. And the very first question is, what number is the square root of 81? And again, this is one where it's all really, most everything's kind of calculator-wise. And this one, they kind of clue you in that they're not looking for the plus or minus because they just say what number. You know, it's not what number, it doesn't say list both roots. So in this case, square root of 81, you get 9. Okay, no big deal there. All right, second question. Same kind of thing, but this one they change it up just a little bit, just to make sure we hit all the words the way they set up here. It says, what is the value of square root of 100? Again, kind of keying on that one, it doesn't say values or list both the roots or anything. Just what is the one value of square root of 100? So that one's 10. Okay, now here's the one where they kind of clue you in, because this one says find all roots. Find all real square roots of, and it does say real, so let's make sure we get that one in there. So find all the real roots of the square root of 25. Okay, and for that one, again, they do tell you that it's all the roots. They'll tell you to separate the answers with a plus or minus. So for this one, when they do the square root of 25, this is where they want the plus or minus. So just plus or minus 5. And again, test-wise, you can do 5 and negative 5. Okay, now here's kind of the I guess kind of trick question that goes with that one. This is, we'll call this one 3A. So same directions as number 3, but this number is going to be the square root of negative 49. Okay, and then for that one, the key word is it's the real root. So if we do, now we've just gotten finished at the end of chapter 10 talking about the imaginary roots you can get with this, the complex numbers. So for this one, can you get a real number answer with negative 49? Now we can get the imaginary answer, right? So you could tell me it would be 7i, but they say, all right, we're not wanting that part. We're not looking for the imaginary answer. If you do this one, it's not a real number. So if it's not real, for that one, that means there is no solution. So yes, we can get an answer that's imaginary, but we're not looking for the imaginary answers. Okay, so the wording on those, just be careful with the wording. And again, it should be pretty straightforward with the way they've set this thing up, so hopefully it's not too tricky as we're going through these. Okay, so similar to the first couple ones here, this time it's simplify. And again, if it says simplify, they just want one answer. They're not looking for the pluses or minuses. This is one that's just giving the answer. And if you have square root of 27 over 75, a couple different ways you can do it. The first thing they're going to have you do for this one, though, is what they want you to think about is neither one of these are perfect square root numbers. So you have 27 over 75. The first thing you want to kind of look at on this one is that if you have 27 and 75, you can divide them both by 3. And if you divide both the top and bottom numbers by 3, that makes it 9 over 25. And if it's 9 over 25, square root of 9 would make it 3. Square root of 25 would be 5. And then that would be the number that you're looking for there. Now, and let's just say you're going through the test and you don't see that you can divide them both by 3. This is one of those that you could take the 27 and break it down. That would be 9 times 3. And you can do the square root of 9 and make it 3. And then square root of 3. With the 75, you can make that 25 times 3. Where again, you can do the square root of 25 and make it 5. You have the square root of 3 left on the inside. And then from there, you could see that, okay, you've got the square root of 3's. You could just cancel those out and get 3 over 5. Doesn't matter how you get there. So you can just, if you see that you've got something here, you can divide them both by 3, go for that. If you happen to think, all right, I've just got to break them down and then cancel out what I can do, same thing. It doesn't matter how you get there for that one. Either way is fine for what you want to do. I would say that there's no wrong way to get the answer, but technically there are wrong ways to get there. So let's just say there's multiple right ways to get the answer. Okay. For 5, basically the same thing. This one says evaluate. It's still pretty much the same thing as the simplify part. This one, we'll do a couple of different ones here. And maybe it's the negative square root of 144. Okay, square root of 144 is 12, and in that case the negative is out front, so you just put the negative in front. So it's the negative of the square root of 144, so that's just negative 12. Okay, for the b part of it, put the negative on the inside. And again, that's basically the same thing as the problem we had a couple of ones before that. If the negative's on the inside, that one is not a real number, no solution, whatever they want to call it there. Okay, so evaluate, simplify, whatever how they want to say it for this part of it. It's still the same thing. You're still just taking the square root, working with it as much as you possibly can, and just breaking it down. Okay, number 6, this one is asking you to, again, just sticking with the directions here. Simplify the square root of x to the 64th power. And what they're looking at for this part of it is they're making you think about that. Now again, you don't want to have to write the x's out 64 times. All they want you to think about on this one is that when you're doing the square root of 64, x to the 64. That technically this is to the second root, and that's where you can just take the 64 and divide it by 2. And 64 divided by 2 is just 32. So that one you've got x to the 32nd power. Okay, 7. Pretty much along the same lines. The only thing they do different now is it's still simplify. but now they give you a number and a variable inside the square root to go back and simplify. And so far, everything we've done, they've all been perfect square roots up to this point, still perfect square roots. That if you square root 81, that's 9. And if you do x to the 10th divided by 2, that's x to the 5th. Okay, and then for 8, they go from square roots. Then on number 8, they change it to third roots. So this one's a third root of 64. And again, you have a couple of different options on this one. Probably the first thing you want to do, and again with third roots, as long as we're doing all the perfect square roots of these that you're going through, probably the easiest thing is just if you're going through third roots, you can think about the list of numbers that would be to the third power. 1 to the third would be 1. 2 to the third would be 8. 3 to the third would be 27. 4 to the third would be 64. So for that part of it, if it's a perfect square, now if you go through this and it's a cube numbers, if you've got the list of perfect cube numbers there, if we had 5 to the third, that would be 125. If it's one of those perfect numbers where this number to the third power comes out to that part, that's where that basically you can go in and take that 64 and rewrite it as 4 to the third power. And as long as you've got the third root and the third power, they cancel each other out and just get 4 for your answer. Now, the other thing you could do is you could take the 64, and start doing the factor tree and breaking it down. If you do that, you wind up getting 6 2s. And because it's the third root, everything's in groups of 3s. Well, there's a group of 3s that's here. There's another group of 3 2s that's with that one. 2 times 2 will get you 4. So this is probably the first option is more probably what we're looking at. This is one that's probably like a second option. You could get the answer this way. It's probably just not the way that they're looking at having you get the answer for that part of it. Okay, and finally when you get to number 9, this is the first problem that you get on the review that's not a perfect square root number. Yep, so this is the one that you have to break down, and you can either do it by taking the 45 and breaking it down in terms of the factor tree. You can do 3 times 15. 15, break it down, make it 3 times 5. So that 45, you can make it 3 times 3 times 5. Then once you get a prime number, and again, the big 4 on prime numbers, really it's the big 3, 2 3s and 5s. That's your big 3 prime numbers. 7 is kind of the next one in there that's used a good bit, but not near as much as the other ones. And then you're looking for pairs of numbers. So there's a pair of 3s, so I can take the 3 out, and that's going to leave you with a square root of 5 on the inside. Okay, so that's one option. The other option you could do, and it's the same answer either way, it's just how you want to look at it. If you can think about a perfect square number you could take out of that, you could take 45 and just rewrite it as 9 times 5. And then you know that the square root of 9 is 3. 5 is prime, so there's nothing you could do with that. So you can make it 3 square root of 5. And again, which way you go with it, it doesn't matter. It's just whichever way that you see it best, whether it's the first way or second way, either way is fine. It's just depending on how you've gotten used to seeing them and how you want to work through it there. Okay, number 10. Same thing on number 10, just the numbers get a little bit bigger. Let's go square root of 245. Okay, now, and again, the bigger numbers, it may not be that you've got a perfect square root number jumping out at you for this one. So this is one of those, with 45, I had the number, I can see 9 times 5, 245, I don't know. So this is one you just have to kind of break it down and see what you can get. You can divide it by 5. So if you do that, that's going to be 5 times 45. What, 4, 20, 45, that's 49. Okay, and again, hopefully when you see the 49 that you realize that's 7 times 7. So again, whether you look at it as 5 times 7 times 7, and realize you've got the pair of 7s you could take out and leave 5 on the inside. You know, or you could look at, if you were breaking this down, that you had square root of 45, 245, that as soon as you broke it down is 5 times 49. Well, 49 is that perfect square root, so you can take square root of 49 and make it 7. Again, either way you go, it doesn't matter. You get the same answer either way. So it's just whichever one that, again, you kind of think looks the best to your eye when it comes down to it. Okay, 11. Same directions. Still simplify. 4x to the 9th. And this is one of those that if you look at it, square root of 4 is a perfect square root, so this is where we kind of break it up in 2 parts. Because the square root of 4 is 2. X to the 9th. If you take that exponent, second exponent there. If you take the x to the 9th, it's a square root, so it's root 2. If you take 9 divided by 2, it's not a perfect square root. It doesn't come out evenly, that you've got some leftovers and some remainders. And this is one that you can either do it one of 2 ways. And again, the bigger the exponents get, the more they want you to think about this. That this is x to the 9 divided by 2. And from that part of it, they actually want you to divide the 2 into 9. 2 will go into 9 4 times. 4 times 2 is 8. With 1 left over. And if you divide the exponents, the top number, that's your whole number, that's the exponent that goes on the outside of the radical. Whatever you have left over, that's the power that's left on the inside of the radical. Okay, so the 2 is 2, because that was square root of 4, so that part was 2. For the x, you're going to have x to the 4th on the outside. And then you're going to have 1x that's going to be left on the square root on the inside. And if it's x to the 1st, you don't have to have it. So you just leave it that way. Okay, so the first one where you get any kind of so the first 11, they're all still pretty much similar. Taking square roots or cube roots or some other power and just breaking it down as much as you can. Some you get where it's perfect roots. Some you get where you're going to have some leftovers inside and outside. The very first problem you get that's got any kind of a different look to it is when you get to number 12. Still the same directions. Still simplify. Square root of 45 minus 3 square root of 80. Okay, now don't be that guy or that girl or lady or man or whatever you want to call yourself there. Don't take this where that you're going to do square root of 45 minus 80 and say, oh, that's the square root of negative 35. Remember, it doesn't work that way. That for this one, before you can add and subtract on these, you have to have you need the same number, not the same hashtag. You need the same number inside the radical. Once you have the same number that's on the inside of the radical, then you add or subtract the numbers on the outside. Okay, so as this problem is right now, there's nothing you can do to add or subtract this one. But you're going to have to take these two numbers and break them down. 45, we did that one already. That would be 9 times 5. Take the square root of 9 and make it 3. So that's 3 square root of 5. Okay, for the second one, we've got negative 3 square root of 80. Now again, the hint for this one is this one's square root of 5. So that's telling you you're probably going to have a square root of 5 left here. So if you take 80 and divide it by 5, that comes out to be 16. So if you take the square root of 16, that's 4. And again, the 3 was already here. And once you pull the 4 out, it's basically multiplication. 5's left over, so go ahead and do 3 times 4 and make that 12. Okay, so you pulled out the 16 to make it 4. Do 3 times 4 to get 12, and now you can actually add or subtract the numbers on the outside. With 3 minus 12, that's a negative 9, and the square root of 5 just hangs out on the end of it. So when you're adding and subtracting, the only thing that changes is the outside numbers that's in front of the variable, or in front of the radical. Everything on the inside of the radical stays the same. Okay, 13, pretty much same question. The only thing that happens on 13 is they're going to throw a variable in the mix. So you're going to have 75, the square root of 75w minus 12w. And it's still the same thing. Number, whatever you have on the inside has to be the same. Once you've got the inside part the same, you can add or subtract on the outside. The only thing that's different is because of the variable. Now this is where you can take out the number part and basically say it's the expression. Variable, whatever you want to call it there. Okay, with the 75, that's 25 times 3 times w. So square root of 25 makes that first number out to be 5. 3 is a perfect prime number, so it's going to stay. And the w, again, you need 2 to get it out. There's only 1, so it's going to stay on the inside. And as soon as you've got the 3w, that's kind of your hint, your clue that, okay, this one's probably also going to be square root of 3w. With the 12, you can make it 4 times 3. Have the w attached to the end of it. Square root of 4 is 2. And again, you've got the 3w on the inside. So now that you've got the square root of 3w the same, it's 5 minus 2, which is 3, and then square root of 3w. Okay, so 12 and 13, addition, subtraction. Key thing is, again, you have to have the same thing on the inside of the square root. Once you have that, you add or subtract whatever you have on the outside. For 14, they're going to change gears, and now you're going to be doing, still says simplify. I think this is one even in the directions above that, they'll tell you to find the product. So this is where you're going to multiply. Square root of 2c times square root of 6c to the 7th. Okay, and multiplication doesn't care. Multiplication says, we'll multiply anything you can throw at us, let's go for it. The only thing you do on multiplication is, if you have numbers on the outside of the radical, you multiply those. Whatever you have on the inside, you multiply those. So multiplication doesn't care anything at all about anything. It says, all right, give me the numbers in front, multiply them together. Take the numbers that's on the inside of the radical and multiply those together, and whatever you get, that's what you get. Okay, and once you've done all that multiplication, then you've got to go back and simplify. Now, the only thing on this one was we said that when you're multiplying these numbers together, that instead of making 2 times 6 and making it 12, you can do that, but it's probably better just to leave it as 2 times 6, because you're going to have to take that number. Now, especially now 2 times 6 is not a big number, okay? But when the numbers get big, if you're doing 10 times 60, you don't want to multiply it together to get 600, because the first thing you're going to do is you're going to take that 600 and start to break it back down. So if it was some bigger numbers, if it was 20 times 60, instead of starting with 1200 and breaking it down, just leave it as 2 times 6 and just start breaking down those numbers. And then with the variables, you've got 1c here and you've got c to the 7th, so just write those behind it as well. So it's 2 times 6 times c to the 7th. All right, and number-wise, that's 2 times 2 times 3. And you got 1c and 7c, so altogether you have 8 c's. And now you're just going through and simplifying what you can do. You got a pair of 2's, so take the 2 out. That 3 stays on the inside, so it's good to go. And then for the c's, you have 8, but again, because it's the second root, because it's square root, you're taking 8 and dividing it by 2. And then 8 divided by 2 is 4. And when you divide 2 into 8, it goes 4 times with no left over. So for that one, that C4 goes on the outside. So there's 4 on the outside, and then none on the inside. Yeah. So when you're going through those, just remember that your numbers, you're breaking them down, looking for the pairs. Technically, with the variables, you're still looking for pairs, but instead of writing each single letter out, just remember you're just going to divide the exponent by whatever your root happens to be, whether that's 2 or 3. Okay, 15, still multiplying. The one thing that's different about 15 is they actually tell you to multiply, they don't tell you just to simplify. And this one is going to be a little bit of distributive property. So we're going to have 3 square root of 3 times the square root of 14 plus the square root of 6. Okay, now you still got the same thing. You're going to multiply 3 square root of 3 times both of these, and you're going to have that same thing that when you're multiplying these out, you're going to multiply the outside numbers, and then you're going to multiply the inside numbers. When you do 3 times square root of 14, that 3 is on the outside. On the inside, you have 14 times 3. This one, again, the 3 is on the outside. and on the inside you have 3 times 6. Okay, so from that part, start breaking it down. 14 is one of those numbers where when you break down the 14, it's 2 times 7. It's all prime numbers, and with the 3 that was behind it, well, there's no pairs of anything, so that part doesn't simplify at all, and if there's nothing you can take out, we're just going to go back and multiply all that together. So the 3's on the outside. We're going to do 14 times 3 and make it 42. And it seems like you could simplify 42, but when you break it down, there's no pairs of anything, so that one's kind of stuck. Now with 6, though, that's 2 times 3. So after you've broken that one down, you've got the extra 3 that was behind it, and the 3 was in front. So there's your pair of 3's that you can take out. And again, that 3 was already out front. We're left with that square root of 2, and when you're pulling that 3 out, remember it is multiplication. So for this one, you've got 3 square root of 42. This one you get a 9 square root of 2, and since those two numbers are different, there's nothing you can do to go back and break that one down. Most of the time you do get something you can do there, but with this distributive property, you do wind up with 2 different terms. Now, when we do the full method, usually you're always having something you can get off of. Okay, for 16, still multiplication. Actually, you have 2 different parts here. We've got an A and a B, so we'll get both of these. So for the A part, it's square root of x plus square root of 5 squared. And again, the first thing on this one is it's not just squaring the first number, squaring the second number. That kind of gets you half of what you're looking for. That remember, if it's square root of x plus square root of 5 squared, that means you really need to write it twice. And once you've written it twice, then you get to go back and do the full method. Okay, so then you've got square root of x times x, square root of x times 5. And remember, you're still going to do the same thing with multiplication. You're going to multiply the inside numbers together. So that's x times x. When you do x times 5, well, that's x times 5, or since we're used to always put the number first, we'll put the 5x there. Okay, same thing with this one. We're going to multiply square root of 5 times both of these. So that is the square root of 5x. And then for the last one, you'll do 5 times 5. Okay, and for this one, you have 2 x's. And when we're doing square root, the pair of x's get to go out. So that one becomes just an x. When you do square root of 5x and square root of 5x, that one's adding and subtracting, so you're technically adding 1 plus 1 to make it 2 square root of 5x. And then the last part, you have 5 times 5, which is 25, so when you square root 25, that one comes out to be just 5. Okay, so for that particular problem with the full method, it puts it all together with addition, subtraction, and the multiplication. That if you're doing the multiplying, you have to remember you're multiplying the outside numbers together and the inside numbers together. And then once you've done the multiplication, then you got to switch gears. Now you're back to adding and subtracting. That before you can add and subtract, you've got to have the same thing inside the radical, and then you're adding and subtracting the numbers on the outside. So when you do full method, it puts it all together and makes you do every part of it there. Okay, and for the B part, we're going to have square root of x plus 2 square root of 3, and then square root of x minus 2 square root of 3. And you've got two options here. First thing is, we're going to do the FOIL method, but they also want you to kind of notice that those are conjugates, where it's the exact same expression. We just changed the first sign from positive to a negative. And if you do that, there's a shortcut. That when you multiply two conjugates together, you're going to do the FOIL method, but the O and the I terms always knock each other out. So you're really going to do the FLA method, when you get down to it. That you're going to do the first times the first, you're going to do the last times the last, and that's all the answer you're going to get. So you can go back and do the FOIL method, but just realize that when you do that, those I and O, the middle two terms will always knock each other out. And we can kind of go through and show you here. So if we do x times x, there's our first term. We do x times 2 square root of 3. So that's 1 times negative 2 for negative 2. You got square root of 3x. Doing the next two, you get a plus 2 square root of 3x. And on the last one, you get a positive 2 times a negative 2 for a negative 4. And then on the inside, you have 3 times 3. Okay, and again, biggest thing on those, when you have the extra numbers on the outside, don't get in too big a hurry, because sometimes it's easy to kind of slip past the 2 times 2 and forget the 4. Or same thing with the 3 times 3 on the inside, so just take your time there. But for this one, on the inside, again, you've got a plus 2 and a minus 2. When you do 2 minus 2, that becomes 0. So again, that knocks it down. So now you've got the square root of x times x, which is just x. And then you've got minus 4. If you do the square root of 3 times 3, that's just 3. So that becomes x minus 12. So if you do get the conjugates, if you happen to catch that when you're working through those, just remember that really all you have to do is do the first times the first, and the last times the last, and then work that part out from there, and then you've got what you're looking for. Okay, 17. We're doing square root of 80 over the square root of 5. And again, neither one of those are perfect square root numbers, so there's nothing you can do with those. And again, here's where you kind of have two options. If you notice that you have 80 and 5, you can divide them both by 5. So they want you to go ahead and divide both of these numbers by 5. So you get the square root of 16 on the top and square root of 1 on the bottom. Square root of 16 is 4. Square root of 1 is 1, and if you've got 4 divided by 1, that is just 4. Now, and again, you could have, and most of the time what they really want you to do is if they give it to you as two separate fractions, they want you to go back and think about that as being like one fraction together. Take 80 divided by 5 and make it 16. Whether you put it together and make it one fraction or divide them both by 5 to get 16 over 1. Either way you go, you still get the same answer. So it's another one of those options where it doesn't really matter how you look at it because you're going to do the same thing. It's just whichever one looks the best to you as you're looking at it. And 18. Still kind of fits in with the division part of it. But 18 asks you to rationalize the denominator. And for the rationalizing, we had two different parts. We had the one part where there was one term, like this one is. We had the other part of it where you had two terms, which was a little bit different story. And that's probably the next problem that's coming up here. So with 4 square root of 3, we said if it's just a one-term denominator, all you're going to do is you're going to take the original problem that you have, and then you're going to multiply by the same thing that's in the denominator. So that when you do that, you get 4 square root of 3 on the top. On the bottom, when you do 3 times 3, you get square root of 9. But the square root of 9 is a perfect square root number, so it's just 3. And the top part is 4 square root of 3. And the whole key thing on the rationalizing part is, in your answer, you cannot have the square root and the denominator. That's the whole key thing that they look at when you're going through with the rationalizing part. So as long as the square root isn't in the denominator, that's all you're looking for. The shortcut we said was that if they give you something like this and ask you to rationalize it, you're going to move the square root from the bottom to the top. And on the bottom, you're just going to take the square root off. And if you can simplify this whole number fraction that's out here without the radicals, simplify that. If you're not able to, you don't have to. Okay, and 19, still rationalize the denominator, but this time it's a 2-term denominator. So it's negative 3 over 3 squared of 5 plus 4. So for this one, you're going to take the original problem, and the only thing you're going to do different is, instead of taking the exact same denominator we had like we have for the one term, the one thing you're going to do different is you're going to take the middle sign and change it from a plus to a minus. And and again, the one thing that they don't kind of give to you here is that when you're doing this with the 2 terms, you have to think about those 2 terms as being in parentheses. Okay, the whole purpose of doing that one is that on the bottom you have the conjugates, and on the conjugate part, when you do the full method, again, the O and the I terms knock each other out. So all you're really going to do is you're going to do the first times the first. So you're going to do 3 squared of 5 times 3 squared of 5. So if we do 3 squared of 5 times 3 squared of 5, that's 9. And then 5 times 5 is 25. And then you have the O and the I knock each other out, so then you're just going to do the last times the last. So then that's going to be a negative 4 times a positive 4. So that would be a negative 16. Now, for the top part, there's really nothing, that one it's just normal whatever. If it's full method, you do full method. In this case, it's distributive property, so on the top part, you're just going to do distributive property. So we're going to do negative 3 times 3 for negative 9 square root of 5. Then it's negative 3 times negative 4 for a positive 12. Okay, and again, when you do this part of it, that square root should simplify out, so we've got the square root of 25. So that's negative 9 square root of 5 plus 12 on the top. On the bottom, 25 is 5, so if we do 9 times 5, that's 45. Minus 16. And 45 minus 16 is 29. This is the part where sometimes they contradict themselves with something that they'll do later. because this problem is one of those where, to me, this is where I would take it and break it up in two parts. That you would do negative 9 over 5 and then plus 12 over 29 and make it two separate fractions, see what you can simplify. For this particular problem, they say that's good enough. As long as it seems like everything is simplified, just leave it as one big fraction. Which, when we do this in section 8 with imaginary numbers, they make you break it up as two separate fractions. So, to me, they ought to kind of stick to it. To me, this is the answer I would think about it. Just so it would stay consistent. To me, that would be the answer that I would think you would want. Now, if you do that, that's one of those where just let me know that you've got the right numbers. I just wrote it as two fractions instead of one. You get full credit for it. Because this is what we'll do in section 8, the answer, but for some reason they want it here. That way you can actually see that you can simplify the different parts of it. But again, that's just one little thing they do there. Okay, and 20, finally get a different set of directions. Everything up till now has been simplify, evaluate, break it down, that kind of thing. 20, you get a totally different directions here. It's solve. And you get, again, we're solving radicals, so it's square root of u equals 4. And as long as we're solving, we said there's two things you have to do. First off, you have to get the square root by itself, which this one is already there. Second thing you have to do is you have to square both sides. So once the square root's already by itself here, we're going to square both sides of this equation. And when you square root the squared number, the square and square root cancel, and you get just u. When you do 4 squared, you get 16. Okay, for 21. Same directions, it's still solve. Problem just gets a little bit longer. Let's change the variable. Let's not do u, let's do x. So let's do square root of x plus 12 equals 9. Okay, same setup. You still have to get the square root by itself, which it's already there. Once the square root's by itself, we're just going to square both sides. And again, the square and square root cancel each other out just to get x plus 12. 9 squared for 81. And because you had the extra part of it on the inside, well, now we've got to this point, you've got to just take and subtract 12 from both sides. So for that one, we're looking for x equals 69. Okay. Now, and this is that part where they tell you to check it, go back and check your answers, and be there, make sure everything checks out. We said for this one, as long as we're getting this, we're okay. The only time you have to check anything, really, is when you have x squared. If you have x squared, when you start factoring and working this part out, that's when you actually have to start checking the answers. I mean, technically, you're supposed to check the answers all the time, but if we get down to when we're actually having to do it, that's when you have an x squared, somewhere along the line when you're going through those. Okay, for this one, let's go with square root of x plus 11 equals 5. Actually, hang on. Let's go square root of x plus 11 plus 1 equals 5. Okay, so for this one, you have the square root, but it's not by itself. So the very first thing you've got to do is, when you have the square root, this is what we're keeping on one side. You've got to get rid of that plus 1. So we're going to subtract 1 on both sides. So you get square root of x plus 1 equals 4. Now the square root's by itself, so now you can go back and square both sides. Okay, again, square and square root cancel each other out to get x plus 1. 4 squared is 16. When you subtract 1 on both sides, x is 15. Is that 11? Oh, wait, it is. My bad. Sorry about that. So that's x is 5. And somebody online that's watching this is going to be thinking the same thing. Hey, wasn't that 11? Okay, so it's still that same thing. Get the square root by itself. Once you've got the square root by itself, then, do what you need to do. Square both sides, and then you're good to go. Remember, the only thing that you have to kind of be careful of is that if you get the square root of x or whatever it is you're doing, doesn't matter what it is, if you get the square root all by itself and that equals a negative number of any kind, that's going to be no solution. So just be on your toes on that one, that if that one does pop up as you're going through this one, that if you have square root of whatever the expression is, doesn't matter what it is, if you have a square root of that expression equals a negative number, there's no answer you can get off that. Or no real solution you can get from that. Okay, and then the last few questions. Is where we're dealing with imaginary numbers, the complex numbers, where we're dealing with square roots, but they're square roots of negative numbers, and just working through these. Okay, if you have the square root of negative 48, basically you're going to just do two things. Just think for a minute what the square root is if it was just a regular 48. Well, let's just say if it was a positive 48. Because all we're going to do is do one thing different than if it was just a regular 48. 48, if you start to break it down, it's 16 times 3. Square root of 16 would be 4, and 3 would just stay on the inside. Okay, so if it was just a regular 48, like one of the first few questions that we had back in the beginning, it would just be 4 square root of 3. The only thing you do different, if it's negative, it's the exact same answer. It's still 4 square root of 3. But because of the negative, you just have to put an I in the answer. Now, the I technically goes on the outside of the square root because technically you're taking out the 48. And with a negative, you're going to replace that negative with I squared. But the shortcut is that just go ahead and do the regular number like you normally would do. And with the I variable, you can put it at the end. I think the way they set this part up is they actually like for the I variable to be right in behind the first coefficient. So you can make it 4I squared of 3. And again, that's one of those that if you tell me on the test that, if you did it this way, where you put the I behind the square root, that's okay for me. If you put it on the inside, that's fine. But if you put this and they count it wrong, just let me know. Go back and give you full credit because that one's still the same thing. Just make sure that I is not inside the square root. It has to be separate from the square root when you're simplifying that part. (24) is multiplying. Negative 1 minus 4i times 5 plus 6i. And for this particular problem, it's just full method. So very first thing is just go back and do the full method. They're not conjugates. There's not anything weird. It's just the basic full method. The only difference is we have I instead of X. You still set it up and still go through the same thing here. Negative 1 times 5, negative 1 times 6. That's negative 5 times negative 6i, or minus 6i. Negative 4 times 5 is negative 20i. Negative 4 times 6 is negative 24. And the one thing to be careful of, when you do I times I, that is I squared. Just like if you do X times X, it's X squared. I times I is still I squared. Okay, negative 5 is good. Nothing you can do there. The two middle two terms, though, that's the ones you can add together. Negative 6 minus 20 is negative 26i. And whenever you have an I squared, that's the part you have to take out the I squared and replace it with negative 1. So that's really negative 24 times negative 1. So that would be a positive 24. And then the last thing you do then is take the negative 5, add that with the negative, or the positive 24. And that would be 19 minus 26i. So still the basic full method like you normally do. And again, those middle two terms, you're almost always going to add those two things together. And once you've added those two terms together, this one now just has the different part that with the I squared terms on the end of it, you get to convert that just to a number. And the last problem on the review. This one you're just simplifying the power of I. Let's go with I to the 66. Okay, now it says simplify the complex number as much as possible. It's still the same thing. It's still simplify. That with the powers of I, all you're going to do is you're going to take whatever that power of I is and divide it by 4. So we're going to take 66 and divide it by 4. And let's just see how many times this thing will go. 24. Got 2 left over. Okay, and the whole key thing you're looking for on this one is, what's the remainder? The remainder is 2. And that basically is telling you what the power of I is going to be. So if the remainder is 2, that means your answer is I squared. And that's where we had that little list that if we had I squared, just like we had it back up here, that I squared was negative 1. So then your answer would be negative 1. That basically that's the list that we had in the little chart that we had. That if it's I to the 0 power, that was 1. I to the first power was I. I squared was negative 1. And then I to the third was negative I. So these basically are your answer choices. And those answer choices are based on the power that you have here, which is the same thing as the exponent that you would have there. So the remainder is basically your power, and the power tells you what the answer is going to be. And that's your 4 choices you have.